So one of the questions that came out of the 00 draft of the document by Xiaodong and Paul and Jiwei was, can the root really run on unmanaged anycast? And so this presentation is actually compressed. Oh, there we go. Because some people were saying, well, sure, we can, it works with AS112. So I'm going to zip through a comparison of this with AS112 with some especially security considerations at the end. So there is a big difference between managed and unmanaged anycast. I'll talk about that. And by the way, I want to be clear, I see a big difference between managed and unmanaged. In discussing with other folks recently, I think my view may have more, make it more clear, that the comparison is more clear than other people feel like. So we'll talk also about how the root servers in AS112 use anycast, and then I'll talk about security implications. So the relationship of this talk to what we're doing here is the fact that essentially all of the root server operators, not necessarily all of them, we don't know how some of them are doing, are using managed anycast. We know that AS112 uses unmanaged anycast. That is, that people who are supporting AS112, there is no central checking of the data that they are doing, but that's okay because we don't really care what they're end up saying. And some of the recent protocols, specifically the one that Paul had talked about this morning, the other Paul, or one of the other Pauls. Does anyone else want to be a Paul today? Talk about extending it to use unmanaged anycast. So that is the way, why I'm talking about this today. And again, I may end up saying things in the rest of this where people disagree with my definitions. That's fine. I think that that's actually really good discussion. So for DNS anycast, people expect, users expect, even though this isn't written down specifically, that all the DNS servers on a particular IP address are going to give you the same information. And if that doesn't happen, so if you send a request to a particular IP address, you get back an answer and you say that looks wrong, and you send it again and now it looks right or whatever, if you're really sure that the response is wrong, you as a user, as an end customer, have no way of figuring out really, did a specific anycast instance give this to me wrong? Am I getting it differently? You as an end customer can't look into the anycast cloud and say, oh, this is why I'm getting something wrong. So I have these two definitions for managed and unmanaged anycast. For managed anycast, there is somewhat of an expectation that the administrator of the address will chase down a problem to the best of their abilities. Now, there's a lot of vague words in that statement. One is administrator of the address, and chase down, and problem. However, this is sort of what we expect. We sort of expect that for managed anycast, if someone can consistently get a wrong answer on a particular IP address that is an anycast IP address, that someone who administers that IP address can do something. They might be motivated to do something, even if it's a name and shame. And their doing something might actually have a positive effect. So unmanaged anycast, in comparison to that, is that no one's going to be responsible for it. So a problem could still exist, but there isn't an administrator and there's no chasing down. So this is the way that I've separated managed versus unmanaged anycast. Now, other people might have different definitions, they might have different words, but that's what I'm using here to discuss things like how the root servers actually use anycast. And so we remember that the original motivation was, in fact, really just to get more resilience that against DDoS attacks, if you have 50 or 100 targets, that's better than 12 or 13. But after that happened, once there was a belief in the DNS operational system that we had actually gotten the DDoS problem somewhat under control, I will never say solved, because, again, for the same thing Paul said this morning, is I don't want someone saying, oh, good, he thinks it's solved, let's go attack and prove he's wrong. The motivation for adding more actually shifted not just from we want better DDoS protection, but actually to try to make it so that people who are using the root servers as a service could get better service, meaning shorter round trip times. And we can see this definitely. Some people say, oh, how do you know that that's what they did? Because no one has ever really stated it that way. But they wouldn't be putting root server instances in islands in the middle of the Pacific. That's the part of the map on rootservers.net that I really like. That they wouldn't be doing that for DDoS resilience. They would be doing that specifically for getting better service to certain places.
Excuse me.
Yeah.
You mean rootservers.org?
Yes, I do. I'm sorry. Thank you. But one of the things that comes out of this is that different root server operators are using the same anycast, different address, of course, but the same technology for different purposes. But they're all doing it approximately the same way. That is, that they are providing the same data, they're doing things a certain way, and they're getting the same result, which is that as there are more and more anycast instances, we are getting better service and better DDoS detection, protection. So there currently is good distribution. If you look at the map, there are some notable gaps where, if you look at it both geographically and topologically, that there are large areas which are not heavily populated, but there are large areas where there are no root servers right there. But to date, there really have been actually few reported problems. We have not seen research that says these people here have a significantly larger round trip time. It's probably true, but we have not seen much data on that. Certainly, we haven't seen it much from the one, and people have said, well, why am I so concerned about this? Even though I'm sitting here in China, my concern is not China. I actually believe China is perfectly capable of fixing this themselves, however they want to do it. But you look at Central Africa. Central Africa has some large geographic problems, but certainly some large topological problems as well. So if you're not on coastal Africa, you're sort of, you've got some issues on getting to the closest root server operator. But the interesting thing in all of this is that, in fact, as we've been talking about TCP earlier, the data actually indicates that using anycast with TCP, which conceptually might not work, actually works reasonably well. And there was especially a lot of data on this almost 10 years ago, between 8 and 10 years ago, at OARC meetings and at NANOG meetings, where people did really measure this and said, yeah, there are some problems. The problems are mysterious, but they're also very rare. I think I'm doing okay on time. So let me talk a little bit about AS112 specifically. So the data from AS112 servers, it's really responses to things that aren't really supposed to have hit the net, and therefore those queries really should have never made it off of a local network. And the answers are not going to make any sense. Paul talked about this a little bit earlier. So anycast has actually worked really well for creating lots of these sinkholes, so, for the various things that Paul talked about earlier. But talking about managed anycast for the root zone today is quite different in that the root zone operators sometimes have found problems on some of their addresses. That is, with the AS112, going back to AS112, we really don't hear about people who are running an AS112 instance saying, oh, and I'm seeing something that I didn't expect on my IP addresses. But we have occasionally heard for the normal root server operators that they find that there's data coming out that is not their data. It does not match the root zone. They're all distributing the same root zone, but some queries going to their IP addresses, they get traces, they get something that says this is a wrong address. And so they do actually take this fairly seriously. Now, this whole slide is full of vague notions. It's data that I've heard informally, but root server operators don't really like to talk about this that much. But they will say, oh yeah, that has happened. They also have, the ones who've talked to me about this said that they actually got reasonably good results when they went, chased it down, and it took a lot of effort, but they chased it down and did a little bit of, hey, this looks wrong, why is this happening? This is what I considered managed anycast. When someone sees a problem and takes it seriously enough, because it does really affect them. If a lot of problems appear on one root server operator's address, that would look bad for them. So they do take this seriously. Let's talk about unmanaged anycast or AS112 again, which is just that because it's unmanaged, if there are, it's okay that it's unmanaged because we don't really care about the answers. But because it's fairly unmanaged, people aren't chasing down bad answers. People aren't even looking for bad answers. So there is additional ways to make some changes to the AS112 that's in an active draft that is actually in the RFC editor's queue. So this will come out. That doesn't affect how are the answers and how good are they. But the thing to remember about unmanaged anycast or AS112 is because we don't care about the answers that much, people aren't really trying to get them correct. But there are a fair number of security implications when you're using unmanaged anycast for the root zone, or actually for any zone that you actually care about the answers. I'm specifically talking about the root zone here because this meeting is about the root zone. But if there was a similar meeting about another zone that people cared a lot about, a lot of this would be the same. So if this was the world that some people were speaking of this morning, where everyone is always using DNSSEC for validation, unmanaged anycast would be just fine because, in fact, someone would be able to say, oh, this is bad data, I'm not going to do this. But only in a world where they had a choice of IP addresses to go to, multiple unmanaged anycasts. Because if you only have one address to go to and you're getting bad answers, you're stuck. You can keep asking it, but you're going to keep getting the answers. You're just going to be dead in the water. But remember, as Jeff had said earlier, we actually don't have that many resolvers using DNSSEC. Now, as Jeff pointed out, the IPv6 world would be thrilled with our penetration. But to me, anything less than 80% here really, yes, and Jeff is doing his jolly laugh there, but anything less than 80% here is something where we're saying to 20% of the people, we've now put you in a position where it's really a lot more dangerous for you than it was before. So with if we go to unmanaged anycast and we say, but everyone should be using DNSSEC, we probably shouldn't do it until lots of people are using DNSSEC. Bad responses from requests to the root zone can have really significant negative effects. And let me go into those now. And I still think we're going to get done before coffee happens. One of the things that people have talked about is that when you change these answers, again, and this will only affect people who are not doing validation, but when you change the answers, there's lots of commercial reasons what you can do. You can change the NS record so that you can get people to go to a place you want them to go. And the way to do that is you start at the TLD and such like that, so that the web clients might go there. Or another one that has actually been discussed is that the web clients think that they're going to this, but they go to a site that actually disparages it. Now this is about reputation. There are also certainly security issues that commercial companies can use, suck down the traffic so they can watch it and then pass it along, especially for non-HTTPS traffic, suck down the email, things like that. So there's lots of things you can imagine that someone can use for commercial. I put that before this slide, which is about malware. I think malware is one of those words that you see too much on slides. So I really actually considered that the moving stuff around to get people to go to a different one. But you can also use it for using anycast to get malware out onto someone's system. So one of the things that I think is also interesting about this distribution of malware is that remember that the glue records in DNS are in fact not signed. Now, when you get glue records, you're actually supposed to look up the names again, even though you've gotten the IP addresses. But to be very, since a lot of people who write the recursive resolver software that we use read the RFCs, there is no RFC that says you have to do that. The one RFC that talks about glue records starts using words like care must be taken. That's not should, and that's certainly not must. I would love BII or some other research organization, or Jeff, to actually do a little bit of research to see whether people, in fact, are looking up answers in the glue records. Jeff, you've done this already.
No.
Oh, I'm sorry. You put your finger up like, oh my God, that's great. You've done it. Good, good. Well, and I would love to see anyone who does, and I'm pointing at BII, but in fact, many of the root server operators here also, in fact, have some research going on. This would be actually very interesting, because if the answer is no one just trusts glue records, that they do it, that actually has a reasonable implication for unmanaged anycast. It's not the only one, and again, some of the other arguments I've given, I think, should make unmanaged anycast look fairly scary to you. But this one, I think, is actually quite easy, given that they aren't signed by DNSSEC. You had a quick one? Because I've still got a couple slides.
I just wanted to say, there isn't really a requirement that you go look up the glue.
Correct. That's what I showed here.
But you mentioned a moment ago that you're supposed to look up the glue, look up the records that you get in glue, and that isn't actually a requirement. And even DNSSEC does not ask you to do that, because ultimately you're going to send a query to the server that was so designated in that address record, and it either speaks the right key or it doesn't.
Right. Exactly right. One of the things that unmanaged anycasts also allows people to do is to be able to do what I call fractional attacks, attacks that are actually really hard to detect, because for one thing, BGP visibility is very low. So if you are doing an attack on a very local system, because remember we were talking about, this anycast might be in hundreds or thousands or millions of ASs. Because the visibility is low, only certain people might see the attack. But also, an attacker can actually set up their node very intelligently so that the attack only happens very rarely. So even if someone says, I even think I know which node is doing it, they then go back, no, they get a perfectly good answer. So they can do it just enough. And we see this with spam all the time, where the people who create spam figure out exactly how often they should be sending it in order to give the greatest penetration. There is also the thing where an anycast node who's sending out bad answers might only do it to certain query addresses, the equivalent of spear phishing in email. So if what you're doing this for, you are a company who wants to send, to redirect only for certain people, you look for the address of their recursive server. Or if you're a government who wants to do something, same thing, that you can actually do that in a very narrow thing. And it will be very hard to detect for anyone outside of that. And again, same thing with only doing the unsigned glue records if the attacker happens to know that the people who they care about aren't in fact looking things up. So my feeling is that unmanaged anycast gives a lot of new opportunities that we don't currently have. And this isn't nearly, when people say, it's like unmanaged anycast is like AS112, that's only true for when you're thinking of AS112 as important, and most of us don't think that that is the case. So I think I did this with a few moments left, and Warren has his hand up.
So two really quick things. I think there's a really interesting example, I think it was last night or yesterday, depending on what time zone you're in, of something that's both managed and unmanaged, or shows both of the problems. Somebody posted on the DNS Ops mailing list about the inability of them to resolve, I think it's targetly.co.
Yeah.
And there was a lot of sort of flapping around trying to figure out which, and they were querying 8888. And there was much sort of flapping around of trying to figure out which particular set of nodes they were querying, if it was affecting everybody or just them. And so that sort of shows some of the problems with unmanaged type stuff. It's hard to figure out where the data comes from.
Right.
Because it is actually a managed address. Eventually, somebody from Google got on the thing and poked around and discovered it was some specific set of GoDaddy nodes, also anycast, that were not giving answers in some places. So that sort of shows if it is a managed thing, somebody eventually hopefully tracks it down. But figuring out who the actual person is often tricky. The other thing is you mentioned the AS112 and the DNAME draft.
Yep.
The whole reason that draft was written is because AS112 is unmanaged. And so getting AS112 to make any changes, or getting everybody in AS112 to make any changes, like adding a new zone or removing a zone, becomes really difficult. And I think that's a useful thing to keep in mind, that if one deploys an unmanaged anycast something and you want to make any changes, you have a very hard time trying to get everybody to coordinate and do stuff.
Right, and especially with the root zone itself, because we have seen occasional changes in the past, for example, with changing NS records and such like that.
Or if we decide that something's not going well and we would like to turn this all off as a thing, If
or
launches in 2 years' time, we discover something real bad is happening. You can never unlaunch it.
We've also talked about changing the algorithm for the root signing key, and with a lot of stuff up front. So, anyways, other questions, James?
So 2 comments. If you go back a few slides on some of the problems that you mentioned, some of these, not this one, the one after. Okay, next slide. Wait, so go on. Yes, that's one.
Which one? This one?
This one.
Yeah.
So some of these problems that is being listed here already existed today.
Sure.
And it exists whether it's managed or unmanaged.
Yes.
Or whether it, and that was one of the motivation of why DNSSEC was created in the first place.
Yeah.
To prevent all this commercial advantage or whatever.
Right.
So that's one comment, that it's not really a problem of managed and unmanaged.
It's not a new problem for it. That unmanaged simply gives the attacker many more places where they can put stuff.
So the other point is that I think it's one end to call it unmanaged versus managed, but there's actually somewhere in between.
Sure.
That is called managed coordinated.
Yeah.
Or coordinated unmanaged.
Right.
Anycast. And I think despite AS112 being unmanaged, it's actually a coordinated. No? Loosely. Very loosely.
Right. So that's why I put it all the way on one end. But I think you're right that in some of the models, and possibly within the model that
Vixie.
Paul Vixie, I call people by Paul, by their first name, but that Paul Vixie had said this morning, it may be somewhere in between unmanaged and managed, that there may be some things in there. And we don't have really definitions on this, so.
All right, so Johan, and then we're up to the break.
So short comment. So going into the Paul Vixie draft, one of the assumptions is that we want to have a really large number of servers to be able to withstand, for instance, DDoS attacks. So I will not go on record saying that we can withstand any DDoS attack. That's usually a bad idea. So I will not say that. But I will make the observation that some years ago we saw, well, let's call them a certain number of a certain size, DDoS attacks against our root infrastructure. Today, we see more attacks against the TLD infrastructure. So, if we're really talking about DDoS here as a primary driver, perhaps the horse is already out of the barn, because the problem has already sort of moved further into the infrastructure. I'm not saying we won't see any more attacks against the root, because we sort of see them periodically. I'm saying attacks against the root is perhaps not the problem. And if the solution we're designing here is just for the root, are we really solving a problem?
Okay, great, thanks.